An IQ test is designed so that the mean is 100 and the standard deviation is 13 for the population of normal adults. Find the sample size necessary to estimate the mean IQ score of students or statistic students such that it can be said with 95% confidence that the sample mean is within 6 IQ points of the true mean. Assume that the population standard deviation is equal to 13 and determine the required sample size using technology. We're going to be doing this by hand. Then determine if this is a reasonable sample size for a real-world calculation. So we want to find the required sample size and rounding it up to the nearest integer. Okay, so the first thing we need to do is we need to find the critical value. When we look at the formula to find the sample size, it's going to equal the critical z-value times the population standard deviation divided by the margin of error squared. So if we want to be able to first find the critical z-value, we need to determine what is the confidence level. Well, the confidence level is given to be 95%. So to find alpha, if we convert 95% to a decimal, 1 minus 0.95 gives us 0.05. We're going to take that alpha and divide it by 2. So 0.05 divided by 2 is 0.025. Okay, so that represents the area that's to the right of the standard normal distribution, which is the z distribution. So what we're concerned and what we want to find here is that critical value that has an area to the right of 0.025. Okay, so we know what the area is. So we want to find the area that's in that right tail, which we are given the area in that right tail, which is 0.025. And what we do want to find is the critical value, or the z-value, okay, that has an area to the right of 0.025. Okay, so we can go ahead and use StatCrunch for that. So let's open this up. Okay, so because we want to find the critical z-value, we're going to go to Stat Calculators, and then we're going to use the normal calculator. We want to make sure that it's in the right tail, so we're going to change that to be greater than or equal to. And then what we're going to do is put in the area of 0.025, and then that gives us a critical value of, rounded to 2 decimal places, of 1.96. So 1.96 represents the critical z-value. Okay, so now that we have that, in step 2, let's go ahead and write that down. So the critical z-value is 1.96, and let's gather the other information that's given in the problem. Well, we know that the population standard deviation up here, assuming that population is equal to 13, and then the margin of error, it says here that it's within 6 IQ points. So therefore, it's going to be 6. Now we can go ahead and then plug it into our formula. So we have 1.96 for the critical z-value. We're going to multiply it by the population standard deviation of 13. Then we're going to divide it by the margin of error of 6. And then we're going to square that result. So let's go ahead and calculate that. So we have 1.96 times 13. And then we're going to divide that by 6. And then we're going to square that result. And that gives us 18.03. Now they want us to then round up to the nearest integer. So we need to round that up to 19. So therefore, and again, the reason why we round up is because you're dealing with a sample size. Okay, so that means that this 0.03 represents another whole number as a sample size. So therefore, we're going to round this up to 19. So let's go ahead and put the answer in here, 19. And there's our answer. Now the question says, would it be reasonable to sample this number of students? Well, since we found that the sample size is 19, it would be reasonable because it's a fairly small number. So we would say, yes, this number of IQ test scores is a fairly small number. So that is our result.